Of the three videos, that is the sine rule, the cosine rule, and the area of the triangle, this would be the second video, that is the cosine rule. The cosine rule primarily associates the three sides with each other along with one angle. That is, if I have this triangle and I have knowledge of, let's take that one of the angles, let's take A, then I can pretty much find the opposite side associated with angle A using the knowledge of the other two sides, that is this one and the one over here, the two remaining sides. So I repeat, the primary idea for the cosine rule is to find a side or an angle when you have knowledge of the other two sides. So why does this become interesting? Now, just before I get into the formula, let me give it a little perspective. So let me try and keep this to the center, and maybe then it will be helpful. Yeah, there we are. And let me have this. So let me make this a radius around over here. Okay, so this is the radius with this length. Let's call it as AX. That's the radius. So I'll try to move around this and see what happens to the opposite side A. I repeat, what I'm going to try and do is move this length AX along that curve, okay, along that radius, in order to see what happens to the length A. If I take the point X out to this point, then you will notice that this length A has reduced. Okay, A has reduced over here. If on the other side I take this length, I take this over here, X is out over here, then what is happening to the opposite side of the triangle is that the length has therefore increased. Okay, now keep that on the mind as we get into the formula. So here we are. I'll just get rid of those understandings that I drew. There we are. Let us presume that the other two vertices are B, and that's a B over there, and I got a C, and that's my C over there. The formula goes in this manner, that A square is equal to B square plus C square, B square plus C square, okay, minus twice BC, 2 times BC, times cos of the angle opposite to the side, that is cos of A. Looks very complicated, isn't it? Let's try and understand this. What does it say? It says that the two of them are associated. the angle, this angle over here, causes the length of this side A. These two are very much related. And as the angle changes, the side A also changes in length. I showed that to you a little while ago. And in accordance to that, the side B and C. Now B and C are actually the, let's say, the ones that guide the length BC, isn't it? The sides B and C would be, as they change, the side A will also change. So all the three have an interdependency. So how do I place it? Let's say if I have a square. Let's see this again. So what is A over here? A is actually the side opposite to the angle that is in use. That's the first thing you must understand. A is associated with, A will be the angle that is in use over here. So if I'm going to use, let's take a B square. Okay, I wish to find the side B, and that's a B square. Then in that case, I'll be using a cos B over here. The rest of the two are the other two sides, which means this would be equal to, the other two sides are A square plus a C square minus twice AC cos B. Similarly, if it were to be, let's take C square. The side is C square. I wish to find C square. In that case, it'll be, you're going to connect it to cos C, cos of the angle. That's C over there. And therefore, the other two sides will be squared, and the sum would be done as a square plus a B square minus twice BC. Okay, so try to remember this in this manner. Let's take another way. Let's just put this out in another form. Let's take another triangle over here. And I got this to be as P, Q, and R. And the letters opposite to it is P, and that's an R, and that's a Q. So we wish to find the length Q. Okay, I wish to find the length Q. What would that be? Q square equals, now remember, Q is associated with, Q is formed due to the angle at Q. Okay, so I want to take the cos of Q over there. So I'm going to have a P square, the remaining sides are P square and R square, minus twice PR cos of Q. Okay,